In this example, we're going to find the equation of a sinusoidal curve from the graph. So we look at the graph shown and we recognize that we need to choose whether it's a positive sine curve, a negative sine curve, a positive cos curve, or a negative cos curve. And we see the graph most closely represents a negative cos curve. So our parent function is going to be y equals negative cos x. Then what we want to do is determine the phase shift. Well, the first point of a negative cos x curve is one of the minimum points. And we see that the x value of this minimum point is 2 squares in. But each one of those squares has an index of pi over 5. So the scale is pi over 5. So we can say that the phase shift is 2 pi over 5 units to the right. D equals 2 pi over 5. Now, the period is the horizontal length of one cycle. We don't necessarily count from the y-axis. In this case, we only count the horizontal distance of one cycle of a negative cos curve. So this is 8 squares wide. Each one of those squares, again, has an index of pi over 5. So we can see that our period is going to be 8 pi over 5. But we know that the k value is always going to be, the absolute value of the k is going to be 2 pi over the period when we're in radians. And we're in radians because of the index, the scale on the x-axis is in terms of radians. In this course, we can assume the k value is positive, and we can do that because of our chosen parent function and phase shift in working in conjunction. But anyways, we can say that our k value is 2 pi over the period being 8 pi over 5. So that's the same as 2 pi times 5 over 8 pi. We end up with 10 pi over 8 pi. The pi's cancel, and we're left with just 10 over 8, which is the same as 5 over 4. So there's our k value. Our amplitude is going to be we see that our minimum point is at y equals 1, our maximum point's at y equals 5. So our axis of symmetry is halfway in between at y equals 3. And our amplitude is going to be the vertical distance above or below that we go. So we can see that our amplitude is 2. Now, if you don't like figuring it out the way I just said, you can use the formula. The amplitude will always be the maximum y value minus the minimum y value all over 2. In this case, that's 4 over 2, which is 2. So our amplitude is 2. But keep in mind that we're talking about y equals negative cos x. So that means the a value will be negative 2. And finally, the c value, the y value of the axis of symmetry, well, that's halfway in between the max and min points. So we can see just by observation that c equals 3. But if you don't like doing it that way, then you can tell yourself that c is always going to be the maximum y value plus the minimum y value all over 2. 6 over 2 equals 3. So putting all of that together in this case, we've got our a, k, d, and c values with check marks next to them. And we can say that the equation of this curve is y equals negative 2 cos 5 over 4 x minus 2 pi over 5 plus 3. Okay, negative 2 cos 5 over 4 x minus 2 pi over 5 plus